Hi everyone, my name is Francis. Today we'll be looking at factorization, solving a quadratic equation by factorization. Let's take another example. Example 2. This lecture. Example 2. Solve 2x, solve 2x squared minus 5x equals to 3 by factorization. By factorization method. Whenever you're given a problem of this kind, you put them in the general form of a quadratic equation. The ax squared plus bx plus c that I gave in the beginning of the lecture, in the beginning of the lesson. So I say, you put them in this form, minus 3 equals to 0. The plus 3 comes this side, and it becomes minus. So what do we do next? We multiply the first and the last term. That gives us minus 6x squared. Bring out the middle term, write them aside. Look for two terms that when you multiply them, it will give you this. And when you add them, it's going to give you this. And the two terms are nothing other than minus 6x times dot plus x. So that gives you this. So when I add the same thing here, minus 6x, this plus added to positive x, I would have minus 5x. So I will take this term here and replace it with this term in this equation. I would have 2x squared minus 6x plus x minus 3 equals to 0. Then, what do we have? What is common to these two terms? We factor out 2x is common. You're left with x minus what's common? You're left with x minus 3 here. What is common in these two terms? In these two consecutive terms, it is plus 1. So you have x minus 3 equals 0. So on these two sides, you have this and this common. So you factor that out, x minus 3, and then you're left with 2x plus 1 equals 0. Now, what do we do to get what values of x makes this equation equals to 0? So you say x minus 3 equals 0, or 2x plus 1 equals 0. Therefore, x will be equals to 3, or x will be equals to minus 1 over 2. Yes. So, easy peasy. That solves it. At this point, let's take look at. That's it for factorization at this point. So let's look at trying to solving a quadratic equation using the completing the square method. To do that, I would start with completing the square method. Completing the square method, the squares. So let's see. Firstly, I would start with completing the square method using solving the general equation, the general quadratic equation using completing the square method. So ax squared plus bx plus c equals 0. For all a, b, and c being members of real numbers, what this just means is that our ABC values, I just define the values that our ABC can take. Our ABC can only take real numbers. You might want to ask, are there numbers that are not real? Yeah, we'll leave that question for, we'll get to see as we proceed into the lesson. So having done this, our goal here is to solve what value, to get what values of x would give us. We'll make all of this equation to be 0 using completing the square method. So what we'll simply do is simply say ax squared plus bx. I'll move this plus c to the other side of the equation, and you have minus c. The next thing I do is divide both sides of the equation, or try to make this the quotient of x squared here to be x alone. And to do that, I would divide both sides, all the sides, by a. So I divide here by a, I divide here by a, and I divide this by a. Therefore, we'll have x squared plus b over ax equals minus c over a. Now, what do? I'm having an x squared here, and I have x here. What do I need to do to obtain x alone, or to make x here? I mean, I want to express all of this. My goal here is to express this equation here, or to put it in another way, to make x the subject here. You can also think of it in that sense. Make x the subject here. Now I've been able to get to this position. What do I need to do to make x the subject? It's also the same as saying solving for x. Just I'm trying to give you a better way to think of it. So what do I need to do to make that? I want to make this quadratic I have by the right hand side to be a perfect square. And to do that, what I need to do is to divide the middle term, this term, or the coefficient of the middle term here, which is this, divide it by 2, and I'll square it. When I do that, I would add whatever I obtained to the right hand side of the equation and the left hand side of the equation. By so doing, I've not changed this equality here, but my aim is to see that I have a perfect square. So what do? Have this and I square it. Then you have x squared plus b over ax plus, when I have this, I would have b all over 2a. When I square it, I would have b over 2a squared. I'll put that same number, or that same number by the left hand side here, plus b squared over a. B squared over a would be b squared over 4a squared. Now, if you might want to convince yourself that when you apply the same thing I did in factorization, by multiplying the first and the last term, and then looking for two values for which you would add to give you this, and when you multiply them, it will give you this. When you do that same thing here, you find out that you would have a perfect square here, that you obtain x squared plus b over 2a squared equals to minus c over a plus b squared over 4a squared. So you may want to convince yourself by doing that here and see that you will get a repeated you would get x squared, x plus b over 2 and another x plus b over 2. So having said that, you on the right hand side here find the common, take a common denominator. When you divide this by this and multiply the numerator with this, you would have minus 4ac. You divide this by 2, divide this by this and multiply it with this, you have plus b squared. Bear in mind that I can also write this expression as this. I can also write this as b squared minus 4ac over 4a squared. I have not changed anything in this on my right hand side by writing it this way. So x squared x plus b over 2a raised to power 2. Well, when I square both sides, square here, and you square here, you would have x plus b over 2a equals b squared minus 4ac over 2a. So now I now have I've been able to, when I take the root of this undoes this, and you're left with this. From here, what I need to do, I simply move this side b over 2a to the other side of the equation, and you would have x equals to b squared minus 4ac over 2a. Let's see. Minus b over 2a. So bear in mind that whenever you find whenever you take the root of any real number, you have a plus or minus. You always write a plus or minus, because then b squared minus 4ac over this, since they have common denominator, right, you just pick one and have minus b as our therefore other ways I could also arrange this would be to say minus b plus or minus b squared minus 4ac over 2a. Now bear in mind that our answer now would be, or value, the two values of x would be minus b plus a over b squared minus 4ac over 2a, or b minus b squared minus 4ac over 2a. So these are the two values of x that would solve, that would be the answer, or that would solve the general form of the quadratic equation. So be that said, in the next lecture we're going to look at what values the discriminant here. The discriminant is just nothing other than trying to see what values what are the results that I could get when I express when b squared is greater than this value here, and when this value here is equal to this, or when this value here, this b squared, is less than this. So all of these things are what we are going to look at in the next lecture. Thank you all for listening. See you all in the next lecture. Bye for now. Thank you for listening. See you all.